Hey guys, welcome back to your 7.3 section video. This is your chemical properties. Mr. Lewis here with you today. You are in such good luck and good hands, just like Allstate. All right, here is your bell ringer on your screen. Go ahead and make sure you answer up your bell ringer on Edmodo. The picture that you're talking about there is right here. Let's go to right there. That's the picture you're talking about. So if you need to stop rewinding, you can go ahead and stop rewinding. Look at that. I'll leave there for a second. Alrighty, let's go and get started. Your objectives today, you're going to describe two examples of chemical properties. You're going to explain what happens during a chemical change, and you'll be able to distinguish between physical and chemical changes. Dun, dun, dun. Let's go and get started. Ladies and gentlemen, when we talk about chemical properties, all right, we talk about chemical properties. Chemical properties are describe the matter that you're looking at based on its ability to change into new matter that has different properties. Okay, so when we talk about chemical properties, we're talking about the ability of that matter to change into something new. For example, wood has a chemical property of flammability. In other words, it has the ability to burn, because flammability is the ability to burn. It has the ability to burn. Since wood has that ability to burn, it has the chemical property of flammability. However, the result of that burning of that wood, the ash and the smoke, they do not have the same chemical property of flammability. You cannot burn the ash and you can't burn the smoke from a wood fire. So those have a chemical property. The ash and the smoke have a chemical property of non-flammability. In other words, they can't catch fire. So when we look at something, sometimes when you look at substances, it's easy to identify the physical properties of an object typically. Now, you can talk about its size, you can talk about its color, you can talk about its shape, you can talk about its density, you can talk about those different types of things. But when you look at chemical properties are harder to describe just from visually seeing. In other words, you can't look at a piece of wood. If you didn't know that wood burns, you couldn't look at a piece of wood and say, hey, that burns. Okay, that'll catch on fire. You can't see the chemical property, but typically you can see the physical property. Now, that doesn't mean that all the time you can't see the chemical property, but those are much harder to observe. Chemical properties are much harder to observe on substances. Now, when we talk about the different properties that these things have, we're talking about its characteristic property. Now, characteristic properties are the most useful properties we use in identifying what a substance is. Okay, so characteristic property, the properties that are most useful in identifying that substance. Now, here is a visual concept. We're going to go ahead and watch this visual concept real quick on comparing physical and chemical properties. If you'll come up, there you go. And dun, 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 you can do it. I know you can. Here we go. Go ahead and pay attention to this.
The ability of an iron nail to be bent is a physical property called malleability. The rusting of iron is a chemical change. Iron's reactivity with oxygen to form rust is a chemical property. The food coloring in this water is red. Color is a physical property. Adding bleach to the solution changes the chemical composition of the dye, and it is no longer red. The ability of bleach to make other substances colorless is a chemical property.
Okay, so when we look at chemical properties, you look at physical properties, you can see that those properties are easier to observe, and physical properties are easier to observe than the chemical properties were. Okay, now chemical changes in new substances. What happens when a chemical change happens? Well, when one or more of these substances are combined chemically, a new substance is formed. Now, that new substance has new and different properties, and that's something you have to pay attention to. Chemical change creates new and different substances that have different properties. Okay, an example of this, we talk about. Your book doesn't really talk about it, but an example of this would be NaCl. NaCl, which is something you guys are going to have to learn what that formula is. NaCl is sodium and chlorine. All right. Now, sodium and chlorine, both of those are gases. Now, if you were to breathe in sodium or you to breathe in chlorine, guess what? It's very, very poisonous, very, very harmful to you, and it can actually kill you if you inhale too much of it. But when those two gases combine, all right, they make NaCl, sodium chloride. Sodium chloride is table salt. So two gases chemically combined created table salt. And table salt is good for you. Now, granted, you don't use it in excess, but table salt is good for you. You need to have some salt in your body, okay? But what happened is the chemically changed the properties of that sodium and that chlorine, and those two together, NaCl together, create that chemical formula, that chemical change, created something useful that has totally different properties of it. It's not going to kill you if you have a little bit of salt. Now, if you have a whole bunch of salt, then that's going to be bad for you. Now, what happens during a chemical change? Now, chemical change, we just talked about that. One or more of those substances, those substances, when they combine, they change their properties. All right. So how do you know that a chemical change has happened? If somebody is describing a reaction to you, how do you know that it's a chemical change? Well, you have a change in color, you have a change in odor, you have a production of heat, you have fizzing, and there's other things that happen that tell you that a chemical change has happened. Now, pay attention. One of these things happening doesn't necessarily mean a chemical change has happened. Here's an example. You take Kool-Aid. You put that Kool-Aid inside that jug of water. That jug of water is clear. You put that Kool-Aid in there, all of a sudden it changes color. It changes from clear to red. That is not an example of a chemical change. It's an example of a physical change of solubility. That is not an example of a chemical change. However, if you were to take that liquid that you saw in the last concept video, you took that liquid that had red dye in it, you put bleach in it, and guess what? It turned clear. That is an example of a chemical change because it changed the composition of that substance and changed the color of it. All right. The more of these signs of chemical change that you have, tells you for sure that a chemical change has happened. All right. Now, when we talk about matter and chemical change changes the identity of the matter involved. So it changes the identity of that substance completely. All right, and it is now something completely different. It's the same thing with hydrogen gas and oxygen gas. You have these two gases that are out there floating around willy-nilly. Well, when they combine chemically, and you have H2O, so 2 atoms of hydrogen, 1 atom of oxygen, they combine chemically. All of a sudden, you have liquid water. All right. So 2 gases combined chemically, you have liquid water. It is something totally different. It's 2 gases, and all of a sudden they combine. Now they turn into a liquid. So when we talk about chemical changes, the matter and the identity and the matter of the matter is changed completely in a chemical change. Here's some examples of chemical changes. The hot gas from the space shuttle being launched into space. That hot gas is an example of chemical change. Remember, production of heat. Since this is hot, since this is heat, the gas is being expelled as hot. That tells you chemical changes happen. Here, this lady is smelling sour milk. The milk has changed its chemical makeup because of the bacteria in there, and now it's changed into a new substance. And so you have that sour smell, all right? That is a sign of chemical change. Effervescent bubbles. If you have Rolaids or something, you put Rolaids into a cup of water, it's going to start bubbling. That bubbling is called effervescent bubbling, all right? Those effervescent tablets, when they start to bubble, that's a sign of a chemical change. And down here you have the Statue of Liberty. Now, the Statue of Liberty, when it was originally designed and built, it was actually a orange-brown color because of the copper that it was made from. But over time, copper's reactivity with oxygen changed the patina of this, the color of this, to green. So now we always think of the Statue of Liberty being green, but in reality, it actually looked like a penny when it first came to us. Now, physical and chemical changes, the difference between these two. Physical changes do not change the composition of a substance, but chemical changes do. So when I took this piece of paper and I ripped it in half, okay, that piece of paper did not change. It is still paper. That is a physical change. So when I rip this in half, it is still a chemical or physical change because it's still paper. However, when I take that sodium and that chlorine atoms and I combine them, a chemical change has happened because now it's not 2 gases floating around. Now it's a solid known as table salt. Okay. The composition of the object, type of matter makes up the object, and the way the object the matter is arranged in an object tells us if it's a chemical or a physical change. Now, a thing to also think about when we talk about physical changes versus chemical changes, many of those physical changes we can easily reverse. Now, granted, I cannot take these 2 pieces of paper and put them together and all of a sudden I have a whole new fresh sheet of paper. No, I could tape it and I could still use this on one side and I could still use this paper. It's easily reversed. But I can't take those two atoms of hydrogen, one atom of oxygen, and just easily separate it. I have to go through a process of electrolysis in order to separate those two atoms. So I have to go through another chemical means in order to change those substances, reverse those substances. Here is another example, another video for you to watch.
Breaking
And this
a
is
piece of chalk in 2 or more pieces is an example of a physical change. Regardless of how many times the chalk is broken, it is still chalk. The physical properties of size and shape are altered, but the chemical properties of the chalk remain the same. An example of a chemical change is baking a cake. When baking a cake, eggs, flour, sugar, oil, and other ingredients are combined. Each ingredient has its own set of properties. If the ingredients are mixed together and baked, something completely different is created. The heat from the oven and the interaction of the cake ingredients cause a chemical change.
Okay, so that's an example of physical chemical change right there. That cake right there, number, I love some cake. That cake right there, the different ingredients, when those different ingredients were combined together and created, put into the oven and heat was applied, guess what? Those things created a different substance. And imagine trying to break that cake back into its original substances. It's going to be extremely difficult to get the egg back out, the flour back out, the milk back out, that kind of stuff. It's going to be very, 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 very hard to do that. Whereas with a physical change, you can. Guess what, guys? It's time for your review. It's review time. It's time for your review. So go ahead and stop me here so you guys can go ahead and take your notes. Just as a word of warning, you've only got one more chapter of me actually giving you these reviews. After that, chapter 9 and above, you're going to have to start taking on your own notes for the review part. I just do this so you guys have that ability to do that. So I'll be quiet. Okay, guys, I hope you guys enjoyed that video. This is your 7.3 video. It's Mr. Lewis here with you again. I'm going to go ahead and sign off, and you guys have a great day, and I'll see you in the future.